So we meet again soon, hopefully. Hello, guys. Welcome to another remote lesson with Miss Pitt. If you haven't done so already, please make sure you've completed your retrieval quiz. On your student worksheet, you've got your questions. You then need to select an answer and fill that in the table. Come back to the lesson for the answers. So pause this video, go and complete the retrieval quiz. If you haven't done so yet, come back for the answers. Okay, so what colour precipitate would iron-free ions produce? And it's an orange-brown colour. Remember, it produces that rusty colour. Copper-2 ions would produce a blue precipitate. We use sodium hydroxide solution to test for metal ions. Remember, it's the sodium hydroxide solution that reacts with the metal ions to produce the precipitate. The ion that dissolves in excess sodium hydroxide solution is aluminium. If we had magnesium and calcium and they both produce a white precipitate, what can we do to test them further? We can do a flame test, and calcium should give an orange-red flame. Magnesium doesn't produce a colour. Number 6, a green precipitate is produced by iron-2 ions. Copper produces a green flame. The stage of a flame test that helps clean the wire loop and decontaminate it is dipping it in acid. It's difficult to use a flame test on a sample with 2 ions in it because the colours may mix and it would be difficult to identify each colour. And during a precipitation reaction, 2 solutions are mixed and a solid forms. So remember, a precipitate is a solid forming inside of a liquid, and that is why we call it a precipitation reaction. So today we are testing for negative ions. We've looked at how to test for positive ions using a flame test and using sodium hydroxide solution. And now we're going to be looking at testing for negative ions. Now remember, negative ions are non-metals. So you need to be able to describe how to test for and how to identify non-metal ions. Just some keywords for the learning today. We know that a negative ion is formed when an atom has gained electrons and therefore it becomes negatively charged. A precipitate is a solid formed during a chemical reaction, and we know that from last lesson. And if it's insoluble, it does not dissolve, and that's why precipitates form, because they are insoluble in that solution. So, ions form when atoms lose or gain electrons. We've learnt this already. So we know that atoms are neutral. We know that if it loses electrons, it becomes positive. Therefore, if an atom gains electrons, it becomes a negative ion. And we call negative ions anions. The general term for a negative ion is anion. Now, I remember anions being negative because it sounds like onions, and onions make you cry. Nasty onions. Now, remember, guys, atoms will gain electrons to form a full outer shell. So some common ions you need to know about are chlorine. Chlorine becomes a negative ion. It becomes a chloride ion. Bromine becomes a bromide ion. Iodine gains an electron. It becomes a negative ion called iodide. Now, what you'll notice, guys, is all 3 of those ions come from group 7 on the periodic table. Now, remember, guys, group 7, this purple column here, if you look at it on your periodic tables in your planners, please. If you look at group 7, okay, you'll notice you've got fluorine, chlorine, bromine, iodine, astatine, And the reason that they form negative ions, guys, is they're in group 7 because they've got 7 outer shell electrons. They gain 1 more for a faux outer shell, so they become minus by just 1 charge because they've gained 1 electron. So anything in group 7 becomes a negative ion just by 1. So Cl minus, Br minus, I minus, F minus. And if you remember, guys, group 7 from our topic on the periodic table, we know that group 7 are called the halogens or the halogens. Now, the ions, therefore, that form from those atoms are called halide ions. So when you hear me talk about halide ions, I'm just talking about the ions formed from group 7 atoms. Group 6 atoms also become negative ions. Now, because they're in group 6, they gain 2 electrons, so they become negative by 2. So, for example, an oxide ion is negative 2. Some other ions you might know about or you will need to know about. Remember this ion that we talked about being in alkali solutions? Hydroxide ions. Now this is what we call polyatomic. It's made of more than one atom, more than one ion. We've got oxygen and we've got hydrogen. And overall it's got a charge of negative. Now, another 2 ions you need to know and remember are carbonate. I know it's carbonate because it's got carbon and 3 oxygens in it, and it's got a charge of negative 2. So if it's got a negative charge, we know it's an anion. And then we've got sulfate ion. Okay, and again, we know it's an anion because it's got this negative charge. So what you'll notice, guys, is all negative ions are non-metals. You need to be able to describe 3 different tests, okay, for 3 different negative ions. So we've got the sulfate ion. You will need to remember the symbols for these as well. You need to be able to test for a carbonate ion. And you need to be able to test for these halide ions. Now remember, guys, halide ions are just any ion made from atoms in group 7. And what you'll notice, guys, is the ending of the name slightly changes. It goes from a chlorine atom to a chloride ion, a bromine atom to a bromide ion. So let's look at the first test, identifying carbonate ions. Now, you've probably heard of carbonates at some point in school: calcium carbonate, copper carbonate, sodium carbonate. So in order to test if an unknown sample, so you've got an unknown sample, okay, and you want to know if it contains carbonate ions. So what you need to do is you add a small amount of dilute acid to your unknown compound, to your sample that you're testing. Now, if there is a carbonate in that sample, the acid will react with the carbonate and you'll see it fizzing or bubbling. Now, the correct scientific name for bubbles forming is effervescence. Effervescence. And that is a posh way of saying bubbling or fizzing, showing that gas is being released. Now, if you bubble that gas through lime water and it turns cloudy, we know that there were carbonate ions. So looking at this diagram here, you've got your carbonate sample, your unknown sample, okay? It's been added to some acid. As gas is given off, it will travel through the delivery tube. They're bubbling that through lime water, and the lime water should turn cloudy. So it goes from colourless to cloudy if carbonate ions are present. Now, the reason that the lime water goes cloudy, the gas that is produced by a carbonate is carbon dioxide. And if you look, you can see a real photo of this happening. Okay, there's carbon dioxide being bubbled through lime water, and you can see the lime water turning from colourless to cloudy or milky. So what I'd like you to do is go to your student worksheet, click on the link to watch the first video, and that is the video on testing for a carbonate ion. Now remember guys, you add acid to the sample. If a gas is released, you bubble that gas through lime water and it will turn cloudy, and that gas is carbon dioxide. That is the positive test result for carbonate ions. So pause me, go and watch this video. I usually embed them into my videos, however the quality can be poor, so go and watch it following the link and then come back. Okay, so that leads us on to the test for sulfate ions. So in order to test for sulfate ions, the first step is to add a few drops of hydrochloric acid to the sample. Now, the only reason we add that acid is to get rid of any carbonate ions. We don't want carbonate ions being tested for, so we add the acid to get rid of the carbonate ions. Once we've got rid of any carbonate ions, we can then test for the sulfate ions. So we add barium chloride to the sample. And if a sulfate is present, so if there is sulfate ions in the unknown sample, a white precipitate is formed. Now remember, a precipitate is a solid forming. So if you look at this diagram, okay, we've got our test solution in the test tube. We're adding some barium chloride to the unknown solution, and a white precipitate is forming. Now, the reason that a white precipitate forms is because the sulfate ion reacts with the barium in the barium chloride, and it makes barium sulfate. Now, barium sulfate is insoluble, and that's why you get the white precipitate. The white precipitate is the barium sulfate forming from the reaction. So the word equation for the reaction, if you had your barium chloride and you were adding it to, say, for example, sodium sulfate, it would make barium sulfate, that's the white precipitate that forms, and sodium chloride would be left in solution. So identifying sulfate ions, you use barium chloride. The barium chloride reacts with the sulfate in the solution, and it becomes barium sulfate. Barium sulfate. Barium sulfate being the white solid formed. Now, just an application to everyday life. Barium sulfate is insoluble. So if ever you have a problem with your digestive system, which is made up of soft tissue, it doesn't show up on an X-ray. So what they'll do is they'll give you what they call a barium sulfate meal, a barium sulfate drink. Now, when you drink that, it can safely pass through your digestive system because it is insoluble. It won't dissolve and get absorbed into your blood. And it will show up on an X-ray because it's insoluble, it's a solid precipitate. You can see it passing through the digestive system. And that's how they will look at your digestive system to identify any blockages or any problems by giving you a barium sulfate meal and taking an X-ray. Now, task 2, I want you to watch the video on testing for sulfate ions. Pause the video, follow the link, and then come back. Okay, so that takes us on to our final negative ion test, which is identify halide ions. Now remember, they are ions that form from group 7 atoms. So for example, chloride, iodide, bromide. Now, in order to test for halide ions, again, we just add some nitric acid at the start. That's to get rid of any carbonate ions that we don't want to be testing for. So we add some acid to get rid of the any carbonate ions from the sample that might be present. Once we've got rid of that, we can then add the silver nitrate to the sample. So just like we use barium chloride for testing for sulfate ions, to test for halide ions, we use a chemical called silver nitrate. Now, when you add silver nitrate to a sample that contains halide ions, a precipitate will form, a solid will form. Now, if it contains chloride ions, the precipitate formed is white. If it contains bromide ions, the precipitate formed is cream. If it contains iodide ions, the precipitate colour is yellow. Now, I remember those colours because what you'll notice is that as you go down group 7, so remember, if looking at your periodic tables, you've got chlorine, bromine, and iodine. As you go down, the precipitate colours get darker. So chloride is white, bromide is cream, iodide is yellow. So if you look at the diagram, you can see we've got our 3 samples. We are adding our silver nitrate to our samples, and if it contains chloride ions, it gives a white precipitate. And the reason it gives that white precipitate is because it's formed silver chloride. The chloride ion has reacted with the silver from the silver nitrate solution, and it's formed silver chloride, which is insoluble, and it's a white insoluble precipitate, a white insoluble solid. Bromide ions give this cream precipitate because it forms silver bromide, and then with iodide ions, it gives a yellow precipitate. Now, I've got one problemo with this diagram. Look at the chemical formula for silver iodide. What's the problem? What's your problem, Miss Pitt? So if you notice, you've got the symbol for silver, Ag, capital A, lowercase g, and then you've got the symbol for iodine or iodide, for iodine, and it's a lowercase I. Now we know that should be a capital. I've told you lot to be careful with your capitals and lowercases, and now we've got diagrams from Google showing us incorrect symbols. So I've just wanted to highlight that. One of my pet hates. So guys, as I've said, the reason we can test for halide ions using silver nitrate is because the silver from the silver nitrate reacts with the halide ion to form a precipitate. So, for example, silver chloride, silver bromide, silver iodide, they are our precipitates from the reaction. And those are 2-word equations just to show you what's going on. Okay, so that leads us to the final task 3, to watch the video on testing for halide ions. You only need to watch the first 50 seconds. So pause me, but don't leave me hanging. Make sure you come back. Okay, so let's see what you've learnt about the negative ions testing. So what I'd like you to do is on your student worksheet, complete these 3 activities for task 4. It shouldn't take you too long. The first 2 tables, you're just filling in the name of the ions. And then for your 3rd task, you are gap filling to explain the positive test results for each negative ion test. Pause me, come back for your answers. Okay, so CO minus is a chloride ion, Br minus bromide and iodide. OH minus hydroxide, CO32 minus carbonate, and then sulfate. The tasks where you had to complete the sentences, so for a carbonate ion, You add dilute acid, bubble the gas through lime water, and the lime water should turn cloudy. Sulfate, firstly you add the acid to get rid of any carbonates, and then you use barium chloride. If a white precipitate forms, it is a sulfate ion. And then a halide ion, you add nitric acid and silver nitrate. And then, oh, what's happened here then? So what you should get is a white precipitate for chloride, a green precipitate for bromide, a yellow precipitate for iodide. No, obviously I've accidentally typed some extra keys there at the bottom for iodide. Please ignore. So that leads us on to the consolidobs. So can you identify the ions in an unknown compound? So that's what all this chemical analysis has been about. Can we analyze an unknown compound, an unknown sample, to find out what ions are in it? What ions make the ionic compound? So remember, there will always be a metal and there will always be a non-metal. So there's two scenarios. Scenario with compound A, which is the one in red, and then you've got the scenario in blue, which should say compound B. So what I'd like you to do is have a go at completing these questions and identifying the ions that make the compound. So it says an unknown compound, compound A, was analysed. It produced a yellow flame when heated. So that should give us a clue as to what metal ion is in the compound. When dilute acid was added to the sample A, a gas was given off that turned the lime water cloudy, and that should therefore tell us the negative ion. So pause me, go and complete your consolidation task, and then come back. So go and apply what you've learned, come back once you've done that. Okay, so let's go through the answers. Make sure you are green penning. I have asked everyone to do this. So if it gave a yellow flame, it should be sodium ions. If it gave off a gas that turned lime water cloudy, we know that the ions would be a carbonate ion. Therefore, the compound should be sodium carbonate. And the gas that turned the lime water milky was carbon dioxide. And then finally, guys, for the last scenario, it says an unknown compound was analysed. It gave a green flame. Well, if it gave a green flame, I know that the metal ion must be copper. When nitric acid followed by silver nitrate was added, a white precipitate was formed. Well, if they're using silver nitrate, they must be testing for a halide. And if it gave a white precipitate, I know that halide must be chloride. So in that compound, you must have copper and chloride ions, making the compound copper chloride. And can you write the formula for it? Well done if you could. CuCl2. So only one copper ion because copper has got a charge of +2. We, however, need two chloride ions because chloride has only got a charge of -1. So in order to balance those charges to have a neutral ionic compound, we need two chloride ions to one copper ion. Hence this formula CuCl2. Really well done if you managed to get that. Amazing. So thank you for completing this lesson. This lesson for you today will be your last chemistry lesson before your half-term break. So those of you that have been completing the home learning, the remote learning every week, please enjoy a well-deserved restful half-term. Oh, and don't forget to complete your RAG rating. Are you red, amber, or green?